Hello, this is Junichiro Horikawa, and today I would like to try to create a motion graphics animations uh, for some simple algorithm called a bubble sort, one of the sorting algorithm using Houdini. My purpose is to practice my animation skills, procedural animation skills using Houdini. So I guess I'm not gonna make it too explanatory, but just to make sure that you understand what bubble sort is, and let me explain a bit how it works. So if you have random values stored in an array like this, what you want to do is to sort this out from small to big, like this. Now to do this, there are many ways, and bubble sort that I'm going to animate is one of the methods you can do. To do that, you start off by looking at the pair of end values, in this case 5 and 6, and compare those two values together. And if you find out that the first value is bigger than the second value, then you flip it. But in this case, the second value is bigger, so you're gonna ignore it. Then go to the next pair and compare those two values together, and currently the 5 is bigger than 1, so you're gonna skip this as well. And go to the next pair, and in this case 3 is bigger than 1, so if you find out that this case, you flip it to make 1 3, so that 3 comes on the right side and 1 goes to the left side, and goes to the next pair again, and you see that the 4 is bigger than 1 this time, so flip those values together to create a pair like this. Now if you have come to the end of the array, then go back to the end of the array and look at the pair again. Now this is still, the right side is bigger, so just keep it as it is. This one is also, the right side is bigger, so keep it as it is. It's this pair, the 4 is bigger than 3, so flip those two numbers to make it 3 and 4, and goes to the left hand side pair. 1 is less than 3, so keep it as it is, and as a result you'll be able to sort it out, the array from small to big like this. So that's how bubble sort works, and I want to animate this operations as a motion graphics using Houdini somehow. So let's try to do this. So this is the explanation what bubble sort is in Wikipedia. Alright, now let's make a geometry node. Let's make it a dark view and I'm going to create a new controller to control some parameters that I might need. Alright, so let's say I need to specify the number of random values, I guess. So let's set the number of random values using an integer. Let's name this num, and set the range from 0 to say 30. Alright, and let's create the random value using a attribute wrangle, a detail wrangle. Let's create a attribute wrangle, set it as detail. Okay, and let's create a loop first with the num that I have set it right here. So I think I need to have a parameter int num is equal to chi num. Let's promote this, copy this parameter, paste it right here, Okay, like this, and then create a loop. And let's create a float value, a random float value. Rand val equal to rand maybe I plus 1 multiplied by some seed value. Maybe I can have that as a parameter as well. Okay, maybe I can promote this right here. Let's open up the edit parameter interface, unlink, and then bring this up. Let's set the range from 0 to 10. Right, now let's store this in an array. Okay, so let me create, or maybe I can create a point and use that point, set a point attribute with the random value that I've just created. Okay, that might be better because I'm going to, maybe I'm going to create some like simple bar which defines the random values, which the height determines the random height values, and maybe flip those bars from right to left using some interesting animations or simple animations. Okay, so in that case, maybe I could just create some points. Add point set. Okay, and I guess I can just create a point in x direction, so let's determine the x value. Okay, so float x is equal to well, it should be defined by I, but maybe I also wanted to define the size of the space in between the points. Probably I want to make the bar as a box, so I want to also set the size of the box. So let's create two parameters. One is the margin or space using CHF. One is the size of the box using CHF as well. Alright. Now let's set it to some random values right here, and then x equals I multiply by size plus space. Okay, should be okay. Then create the vector of x 0 0, and let's see. Okay, I seem to have some errors. Okay, a spell mistake. Right now, so I have some points on x direction. Let's have the space parameter and size parameter stored in the no control as well. Right. Going back to the array. Okay. Now I want to store this random value that I created and each point as an attribute, so let's set point attrib 0, and I want to use that as a height of the box, so let's name it scale. Since I using scale, maybe I can use copy to point sub later on. Okay, so for the scale attribute, I need to set it as vector in order to use it together with the copy to point. So x and z will be the size of the box in xz direction, so I'll just use size. And for the y value, it's going to be the height value, which should be derived from the random value that I've created right here. So let's say rand val, and that might be too small because it's in between 0 to 1. So let's just multiply it by say 10. Okay, now at this point I cannot really see how high is it, so maybe I'm gonna change it later on, but let's just see if I have created the scale correctly. And looks good. I think it looks good. And if I change the seed, I think the height should also change based on the seed. Okay. Right now I have just created 10 points, or maybe number of points based on this parameters. What else do I need? Well, let's just go with it. Okay, and let's name this initialize. Okay, and let me also set, well, I'm just gonna go with this. And well, since I need to go from right to left, right, and then I have to create a pairs from right to left. So, and I'm planning to use a subsolver in order to create an animation. So I need to kind of define which points to start from to create an animation, or to create a comparison between the first point and second point. So I guess I'm going to retrieve the number, maybe the endpoint number, this point or this point, point number is being stored as a detail attribute, and to use that to determine where we are right now in terms of animations. Maybe I can retrieve this number, and this number could be retrieved by using this number, the total number of the points. So let's name this the current PT is equal to the number, well, number -1 is equal to the last one. So but I want to have this the second last point, so it should be number subtracted by 2. So by having this one, you'll be able to get this one by adding +1 to this value, the current point. Okay, let's do that. Now go into the detail attribute, let's check. Okay, looks good. Right, now next thing, since I'm going to move those points during the animation, but still keeps the point position as the original position as a guide. So let's create the rest. Let's use the rest node to copy the point position as a rest attribute, like this. Right, now let's try to create an animation using solver. And after leaving the solver, I want to visualize this as a square bar or box bar. So let's just do it right now. I'm going to create a box with the size being 1, because I'm going to use a scale to actually scale this box, and copy 2 points and copy this box to each point. Okay, now it seems like it is creating a bar that I expected, but I want these bottom of the box to be aligned on the ground, placed on the ground. So let's translate this box center by just transferring the center by 0.5. Yeah, should work. Now if I change the size, like the size of the box or space, should still work. And if I change the seed, the height of the bar at each position will change randomly, and that's also good. And I can also change the number of random values. Right, that looks good. So this determines the array of values which have been ordered randomly. And what I want to do is to create an animation for the bubble sort, so that in the end the bar will stand from small to highest, the smallest to highest. Okay, now the setup looks good. It's time to create an actual animations. Now before doing that, let's just save this so that I won't lose the process. Okay, so going into the solver, and let's do some calculations. And as always, I am just going to use specs and nothing else. Alright, so I'm going to use that attribute wrangle. And since I just need the comparison between 2 points at some positions based on the detail attribute that I have stored as a current point positions, so I just need to compare 2 points. I don't need to use primitive points or vertices. I just need to use, I guess using detail just works fine. Okay. Now first of all, I'm going to retrieve the current point attribute from the detail. Let's get it. Let's name this curl pt1 equal to I at curl pt, since currently I'm on detail wrangle, and the one that I have just got is the point number for this one, I think. So I want to get the next point number as well. So let's name this curl pt2 equal to curl pt1 plus 1. Right. Sounds good. Now, since I'm going to make an animation, let's think about what kind of animation should I do. So what I want to do is to compare those two values together, the height of 2 points together, and if the one that's on the left is bigger than the right side, then I want to flip it. And I want to make the animation for those flipping. Maybe I can rotate one of the point like clockwise or counterclockwise, and one of the point to counterclockwise on a using different angle, and so that it will be rotated and flipped. If there's no changes, then maybe nothing will happen. Okay, so to do that, I think I need to set some step frames when to do the comparison. Okay, could be like every 20 steps or every 40 frames and so on. So I think I need that kind of parameters. Let's have that int name. Let's name this step using integer. Okay, let's start with a 20. Then maybe I can promote this to no control as well. So going back, open up the no control edit parameter interface, open up the subsolver, drag and drop. Okay, forgot to uncheck this. Okay, let's name this frame step or step frame. Let's bring it, maybe right here is fine, and set the range between 0 to 100. Okay, now let's make a condition when to do the comparison. Okay, so if at frame, so this is the current frame with the modulus step is equal to 0, so to determine if it's in every 20 frames in this case. In every 20 frames I want to check the point scale height together, and then if the left side is bigger, then I want to flip it. I should flip it. Then as soon as I did the flipping from the next frame until the next 20 frames, I want to make an animation to actually shows the flipping. Right, so first of all, I should get the scale value for this point and this point, so let's do that. Let's retrieve that first. Vector scale 1 from the current point 1, point 0 scale curve pt1 is the first scale value, and I'm just going to copy this, paste it, name it scale 2, current pt2 will be the scale 2. Now let's compare it. If scale 1.y, which means the point right here, is bigger than scale 2.y, which is this point scale, then you want to flip it. So what you can do is set point at rev 0 scale current pt1 will become scale 2, so I'm flipping the scale value, doing this one. Do the same for the current pt2, like this. Okay, now I think I also need to flip the point position as well to the original rest positions. So let's also retrieve the rest positions. I'll post one from a rest attribute at current pt1. Do the same for the current pt2. pt2. And do similar stuff like I did right here. So I'm gonna copy this, and for the current p position, current positions at current pt1 and current pt2, I want to place it to, I guess I want to reset to rest position 1 and rest position 2, because the point position will going to be animated, changed after the frames on the other frames, other than the multiplication of 20 in this case, and multiplication of steps. So you want to reset it at whenever you reach to whenever the frame is the multiplication of steps. Okay, now after we have flipped the point, if you find out that the scale 1 is bigger than or scale 2, or if not, then just ignore it. Then after that you want to go to the, if you're looking at this pair, then you want to look at this pair next, to the left side, to go to the left side. To do that, you can subtract pt1 by 1, so something like this. But there could be a chance that we were looking at this point, and if you subtract it by 1, then there's going to be a negative index. So in that case, if current pt is negative, then go back to the right side. So that will be, the current PT should go to right here. So that is equivalent to, oops, should be PT1. Current PT1 should be equivalent to the total number of points which can be retrieved using endpoints negative subtracted by 2. All right. Okay. And the current PT is always a +1 to current PT1. Right. Now, let's also update the detail attribute called current PT with this new current PT1. So set detail attrib 0 current PT should be equal to current PT1, right? So this is the conditions when the frame is equal to 20 or 40 or 60 when the step is equal to 20. Now else you want to actually animate the point position so that it looks like it's flipping. All right. Now to do that, we want to modify the frame values to use it for animations. So what I want to make is the value in between 0 to 1 by converting a frame value somehow. So to do that, first of all, let's calculate the modulus between the current frame and the step value. If the step value is 20, then what you get as a result is in between 1 to 19 in this case, because I mean there could also be a chance to get 0, but that 0 is used with this conditions right here. So inside this condition you always get the value in between 1 to 19. I mean a step -1. So you know the actual range, which means you can convert it into some specific value like ranges like 0 to 1. So let's do that by using fit. So you want to convert f to, which is in between 1 to step -1 to from 0 to 1.0, right? Okay, now let's also try to check the scales for the first point and the second point to see if we really need animation for this frame. So I am going to get the scale for current point 1 and current point 2 again. Vector scale 1 is equal to 0.0 scale, or maybe maybe I could just place this outside the conditions right here like this, so that I can access this scale 1 and scale 2 on both conditions. Yeah, hopefully this works. I think it works. Right. So let's make conditions. If scale 1.y is bigger than scale 2.y, which means if the left hand side height is bigger than the right hand side point, then you want to make animations which looks like it's flipping. So this point try to go right here, and this point try to go on the left side. And maybe I can create rotational animations, maybe using some circular code, circular process, a circular trail. And to do that, maybe I can use like simple trigonometry. Yeah, let's do that. Right, so to get the center, to create a rotational animations between those 2 points, I need to know the center points right here. To get that, maybe I can access to the original point, which doesn't really animate it, and get the center point by between those two rest point positions. Okay, so let's do that. To access to the rest position 1 and rest position 2, I can use R0 rest curve PT1. Did I access to rest position before? Yeah, I did right here. So maybe I can also place this outside the if loop, if conditions, like this, and just use it in both conditions, because rest position should not be changed. Alright, so I can just delete this, and let me create an angle for each point, for a first point and a second point, in order to determine where that point is based on the frame values, which it's currently F. So for the first point, maybe I can move the point from, say, since I want to rotate like this, I think it's going from a pi, which is 180 degrees from the center, if you look at the x axis, to 2 pi, so rotating like this from left to right. For the second point, you want to go from the angle 0 to pi. So let's create a angle which goes like this based on the f value. Right, so float ang1 for the point 1, use fit to change the value f, which is in between 0 to 1, to pi multiplied by 2, which is equivalent to 180 degrees to 380 degrees, 360 degrees. Okay, now using this angle, I want to create the point position, new point position. Let's name this npos1, which is equal to, let's say, now this is the timing when you need to know the center point positions, which can be retrieved by adding rpos1 plus rpos2 and multiply by 0.5, which will create a center point positions, which will going to be the center. And now I can use a cosine and sine to calculate the circular positions together with this angle. So cosine ang1 for the x, for the y I'm just gonna set it as 0, and for the z, sine with the ang1. Okay, looks okay. Now let's do for the second point, which is going to be float ang2 fit f point from 0 to 1, change that from 0 to pi. Okay, and do the similar stuff that I did here. So I'm gonna copy it, change it to npos2 from, so that's the center point positions, and I'm just going to change the angle to ang2 right here. Okay, now I think it's I think I have just created the point positions for each point, which is going to be the animated point positions. Now let's set that as a real point positions by changing the p attribute. So set point attriv p at current pt1 with npos1, and do the same for the position 2. like this. Okay, now let's see if I'm getting the animation that I want. Let's name this bubbles dot. Okay, going back. Let's check with the point. Okay, I do see some rotational animations. Well, seems like the rotational radius is a bit too big. It's a bit too... Okay, I think I didn't set the radius for the rotation, which is right here. Okay, so the radius has to be defined, has been already defined, which is equivalent to the half size of space plus size. Okay, so I need to access to those both values, so I'm gonna copy one of the values, going back, and let's have the parameter somewhere like here. So space chf space, and also a size, and paste the parameter that I have copied to both channel. And for the size, I'm going to rename it this to size. Alright, so I have two values right here, and if I add those two values together, and that will be the distance between 2 points. And what I want to have is the half value of those added value, because I'm going to rotate using this center point between 2 points as a center to create a rotation. So let's, inside this conditions, I'm going to create a variable called radius, and create by adding space and size together and multiply by 0.5, and use that radius multiply with this trigonometry function. Okay, let's see if this works. Play it. Seems to create some cute animations. Now let's also see if the height is also changing. The height of the box is also changing. Okay, going to the left, and I think it's working. Now going back, and let's look at it slowly. So the first set, the first one and second one, the right side is bigger, so it shouldn't flip, and from frame 1 to 20 doesn't really, nothing will happen. And next frame, the next pair is the left hand side is bigger, so it should flip, and as an animation it did flip like this. And the next pair, it also flipped because the left hand side was bigger, and the next pair, the left hand side is still bigger, so it should flip. Now the next pair, the left hand side is small, so it shouldn't flip, but the next pair, it should flip because the left hand side is bigger. And seems like the animation goes pretty well. And let's also look at the end, and if it really goes back to the first to do another loop. So let's increase some frames to thousands, and let's see. And if I finish the left hand side, going back to the right side, and yeah, keeps going. Now I guess I need to know where which of the pairs are checking it right now during the animations, because if there's no like if the left hand value is smaller, then nothing will happen. So it seems like nothing is happening during the animations, but actually it is just skipping. So to show that, let's just colorize those pairs, two boxes in different colors, and I will end this animation creations. Okay, so Let's colorize that after leaving the subsolver. Maybe I can create a another attribute wrangle right after this one, and could be a point wrangle maybe. Let's name this color. Okay, so in order to know which one to be colored differently, I need to find out the pair values, and that is stored inside the detail, which is this one, current PT value. So the current PT number and a current PT plus 1 is the ID that we want to colorize differently from other points. So let's get that value from a detail. Current PT 1 is equal to, or just say current PT is detail 0 current PT, and if the current point number is equal to current PT, or a current point number is equal to the current PT plus 1, then that is the pair that we were looking at right now, or animating right now. So in that case, let's just color it to red. So v at CD is equal to set 1 0 0. Otherwise, let's just color it white. Like this. Okay. Now, do I see any changes? I am not sure. Yeah. Okay, so these are the pairs that we are looking at right now. And if you start from the frame 1, the right hand side pairs are the values that are the points that we're comparing. Now if we play it, you can see that the red pair is moving from right to left, even though there are no switches. Okay, looks good. So in the end, it should end with the values going from the smallest to highest. Now it seems it's a bit too slow, so let's make it fast by making this step frame a bit smaller, like 10. Now it will give you a bit more faster result. And slowly you can see the ladder-like result. Okay, maybe I can make it a bit more faster. Maybe I can set the step frame to 5. Alright. Looks faster. So slowly the long bar is moving to the right side until it becomes ordered. Alright, so here it is. Some quick motion graphics animations to create a explanatory bubble sort diagram, the algorithm, I mean. Okay, so it was just a quick practice to create a procedural animations using Houdini to visualize the algorithm. Yeah, I think it was a pretty interesting practice for me. So maybe I'm going to continue this kind of a series to visualize the algorithm with the animations using Houdini. Right. Okay, so this is it. I'm going to upload this file as well. You can see it, use it for your reference. Right, so I'm gonna end this right here. Thank you for watching, and if you find this interesting, please try to subscribe and follow what I do next. Okay, bye.